So we are taking notes today for a very important lesson. We're going to start that lesson with this premise right here. These two triangles have been charged with a crime. Dun, dun, dun. I should become a graphic artist later in life, right? Aren't those cute little triangles? Anyway, okay. They're accused of being congruent. Oh my goodness. So today's lesson is called Congruent Triangles. We are deciding if triangles are congruent or not congruent. It is our job. We are the judges. It's not trial by jury. You are the sole judge, and you get to decide if these triangles are guilty or not guilty, if they're going to be frowny face or smiley face. It's our job to determine if they are guilty or not guilty. So, of course, when we're trying to determine if things are guilty or not guilty, we have to have some evidence, right? That's what they do in real trials. They collect evidence, they present it to the judge or the jury, and then they decide on the verdict. So today we are deciding whether triangles are congruent or not congruent, and then we're going to cite some evidence to decide. Okay, so here's what we need to talk about. In life, in the real world, in your future job, you want to be as efficient as possible. Here's the deal. If I have two triangles, I can measure all 6 angles and all 6 sides. I can measure 12 things, and then I will know for sure if they are congruent or not. But wait a minute. If there's a shortcut where there's less work we can do rather than measuring 12 things, then we need to learn how to do that. Because in the real world, we need to be as efficient as possible so that we're not costing our bosses more money or costing our company more money, taking time doing things the long way. So this is fancy for saying we're going to be as lazy as possible today. We're going to gather the least amount of evidence needed to prove two triangles guilty of being congruent. That's my thing, being lazy. Okay, so let's start with the least amount of information we could have. You have two triangles, and you know that one side of one triangle is congruent to one side of the other triangle. You have one side. Are they guilty of being congruent or not guilty? These triangles that you know one side about. Connection is off a little bit there. It's obviously we cannot be this lazy. No, no, no. One side will not do it for us. There's two triangles. They have one side congruent to each other. Those triangles are not congruent at all. So totally, bang or gavel, not guilty. One side is not enough information. You're right. Oh, you can't be that lazy. Okay, let's try the next least amount of evidence. Two sides. Two sides of one triangle are congruent to two sides of another triangle. This is called evidence right here. This is how you write the evidence in proper math language. Guilty or not guilty? Okay, good point. I love that you're using a geometric postulate. Through any 2 points, there's exactly one line. So I agree to you that there's only one segment that goes here, and there's only one segment that goes here. I completely agree with you, but I think you're missing something. Think a little bit more. Ding, 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 ding. You thought more about it. Very good. No one told us about angle A and angle D. No one told us about them. So, for all we know, that angle could be whatever it wants to be. So what I'm trying to get you to see is that side, CA, could pivot. It could make a 20-degree angle, a 30-degree, 40-degree, 50-degree. We don't really know. So if that side pivots, then I agree with you. There's only one. I didn't change the length of it. It's still, pretend those are tick marks. It's still congruent. This one still matches this one. This one still matches this one. But whoa, those are not congruent triangles. So without that evidence of the angle, sorry, not guilty. Two sides are simply not enough information. Okay, what about 3 sides? If 3 sides of one triangle are congruent to 3 sides of another triangle, are they guilty? Third time's the charm. So last time we messed with the angles, but when all the 3 sides are locked in, can we mess with the angles? They're locked in too. Someone said, oh, you could do a dilation. You could enlarge it or reduce it. But you can't do that because then the tick marks will leave. They won't be congruent anymore. Yeah. So we decide that yes, they are totally guilty. Those two triangles are perfectly congruent. And instead of measuring 12 things, we only have to measure 6 things. We only have to look at 3 sides of one triangle and 3 sides of another. So that's just one example of the evidence you can collect to prove triangles guilty of being congruent. Now I want you to do is set up your notes to look like this. You can totally just watch and not take notes at all as well, but if you're taking notes, I would like you to organize them like this. These are called congruent theorems. They're going to have an abbreviation, they're going to have a name, and then we're going to draw a couple of examples. There's going to be 5 of them, so there should be 5 rows in your table that you're putting in your notes. Okay, so our first congruent theorem, introducing side-side-side. So this is the abbreviation, SSS, triple S. Its name is side-side-side, and you're not going to write the actual theorem. So you write the abbreviation, you write the name, and then you can draw either example that you want. There's one example where the triangles are connected and one example where they're not connected. So this theorem is called the side-side-side theorem. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. It has a hypothesis and a conclusion. If I can find these 3 pieces of evidence, that's the hypothesis, then I have congruent triangles. I don't have to lift a finger and measure a single angle. 3 sides is enough. It's a shortcut. We're doing shortcuts today. So that's the first one, side-side-side. The next theorem I would like to introduce you to is called side-angle-side. We call this our SASSY postulate. Side-angle-side, S-A-S. I'll read you the fancy theorem, but you don't need to write it down. If 2 sides and, that looks like an important word, the included angle of one triangle are congruent to 2 sides in the included angle of another triangle, then the triangles are congruent. Once again, you're only collecting 3 pieces of information from each triangle, so it's still a shortcut, but this is the evidence that makes them guilty as well. You know how sometimes prosecutors present evidence and the judge is like, sorry, like that's not inconclusive evidence, that's not enough. These people are still not guilty because you didn't show me enough or you didn't show me the right evidence. So we're writing down the ones that are the right evidence, the correct evidence. 2 different examples. You don't have to draw them both, but having one example in your notes would be really helpful. That word included is very important. Notice where the arc is on these pictures. Where the 2 sides meet up, oh, there's an arc. Where the 2 sides meet up, oh, there's an arc. So you find your sides with tick marks, and where they intersect, that better be where the angle is. Because you see this order? That's the order on purpose. Side, then an angle, and then a side. The angle is included. Okay. You're not putting this in your notes. I just want to show you a column of triangles that are congruent and a column of triangles that are not congruent. Take a look. Why are the yeses yeses and why are the no's no's? No. I like that word. I was trying not to say that word because I wanted y'all to come up with it yourself. Good. And I didn't mean to make them smaller. I just wanted to show that they weren't congruent. Don't look at the size. Sorry. The angle in the yes column is between the sides. Between, keyword. The angle in the no column, look. That angle's not between the sides. There's no arc where my sides meet up. Where do my sides meet up? There's no arc there. Where do my sides meet up? There's no arc there. So, the angle has to be between the sides. Really important, between. Okay? So, once again, you still don't even need to write this in your notes, but when you see included in one of the theorems, it just means between. So, if I look at, if I'm given angle B and angle C, what side is included? Well, the one between them, side BC. On the other hand, if I'm given AC and BC, What angle is included? Well, it's the angle where they meet up. So that's what I want you to take away from that. Included really means for us between. Okay, what are some other good theorems? Next one on your list, angle, side angle, ASA. If two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. The order matters. The side has to be between the angles. So you see how it goes. Angle, then tick mark, then angle. Angle, side, angle. Angle, oh, I see a tick mark, that's a side, and then an angle. It goes in order as in the side is between the angles. And the last one that we're going to study today, angle, angle, side. So it does work when the side is not between the angles, not the other way around. We'll get to that in a minute. Angle, angle, side, AAS. If two angles in a non-included side of one triangle are congruent to two angles in a non-included side of the other triangle, then these triangles, without a doubt, are congruent. No, you don't have to check 12 things. You only need to check these 6 things. So notice the tick mark, the side is not between the arcs, and it's okay. Those triangles are still congruent. It's not possible. Those triangles are locked in based off where the angle is and the side is. The side can't pivot, and one of them can't get longer, and so they're guilty of being congruent. There are 2 theorems, which is why I have 2 black sheep here, that are the black sheep. They are they have 3 letters, just like all the other ones, but they do not prove triangles guilty of being congruent. So don't be misled. Don't follow these black sheep, because they do not for sure, they are not inconclusive evidence that the triangles are guilty of being congruent. So here, do not put these in your table. These are not postulates. These are counterexamples. These are the ones that do not prove them guilty. The first one is called side-side angle, and the second one is angle, angle, angle. These do not work, so you will never write them down ever again after you write them in your notes today. You will not write them because they're not evidence. So instead you'll write like not possible or something. This evidence does not work. So notice in my red triangle, do you agree that those 2 sides are the same length? The ones that have a tick mark? They are totally the same length. Do you agree that that angle matches? That angle totally matches. And I even promise that that last side, trust me here, is the same length. But despite all of that evidence, despite all 3 of those things being true, you'll notice this red triangle is not congruent to the blue triangle. So it tricked us. We found 3 pieces of evidence that had S's and A's in it, but it does not work. And sometimes we call it the donkey postulate, because if you spell it the other way, it's a bad word. So you know, when you're solving these triangles, if you get one that spells a bad word, it doesn't work. We're thankful that it worked out that way in the English language. And then the last one that doesn't work is having 3 angles congruent. Having 3 sides congruent is awesome. Having 3 angles congruent just doesn't do it. Look at these triangles. All their angles match. Oh, you match. Oh, you match. Oh, you match. In fact, all the angles are 60, 60, 60 because they're both equilateral triangles. But are those triangles congruent? Are they the same size and the same shape? No. So angle, angle, angle does not work, and side, side angle does not work. Okay, now what do you do first? When you're trying to determine if 2 triangles are congruent or not, some of them will already have markings on them, and sometimes you'll need to add markings. Now, some students start to get add mark happy, and they start to just add markings for no reason at all over the place. So there are legal times when you can add markings, and there's times when you can't add markings, okay? So, one of the times that you are allowed to add markings is when a segment is congruent to itself. It's called the reflexive property of equality, when a segment is congruent to itself. And so, in this picture, yep, I can add a marking because JM is congruent to MJ. Yep, I can add a marking. UT is congruent to CU. Yep, I can add a marking because BD is congruent to DB. What you would not want to add a marking for necessarily would be this one. They are not sharing a side. That is not the reflexive property because they're overlapping, not sharing. Don't know enough. Yes. Okay. One more. There's other times, but this is the other major time you're going to add markings. What would you add markings to for these pictures? We have a theorem out there called the vertical angle theorem. Very good. And the vertical angle theorem says if two angles are vertical, then they are congruent. So every time you see vertical angles, you are allowed to add arcs. You would not do it here because those are not vertical angles, so don't confuse those. The vertical angles have to make the letter X. Those made the letter X. Those made the letter X. Oh, sorry, that's the letter K. That one doesn't work. Okay. All right, let's do it. Let's start determining if triangles are congruent or not. Here we go. This is the good stuff. So you're going to be given two triangles. Your choices of answers are SSS, SAS, ASA, AAS, or not possible. Those are your choices. So you have 5 choices. When you get an example like this, first you say, can I add anything to my picture? And in this one, yes, you can. They have reflexive property of equality for that segment. And now we examine the evidence. We examine it. Oh, I've got 2 sides and an angle. I've got 2 sides and 1 angle. The angle is between the sides. Look at that. Side, side, where they meet up, there's an angle. Since the angle is between the sides, those triangles are guilty of being congruent, and the evidence is side, angle, side. Good. Now we need to name the triangle. We have decided that they're congruent, so now we can write a congruent statement. Does the order matter? Absolutely, the order matters. So, A, B, C. So I need to go in the same order, so I would do C, C, B. Triangle, C, C, B. Order matters. Okay, so we're given 2 triangles. We're trying to decide, are they congruent or not? First, we ask ourselves, can we add anything to the picture? Legally, can we add anything? Yes. Vertical angle theorem. We're allowed to add arcs. There we go. Now examine the evidence. Is it enough? Is it the right evidence? I notice I have 2 angles and a side. So am I going to pick this one or this one? I don't know why it's not circling. I tried to circle in. Well, look at where the tick mark is. The tick mark is not between the angles. Good. So I'm not going to choose this one. The side is not between the angles. So they're guilty of being congruent by angle, angle, side. Very good. Let's name them in the right order. Order does matter. A, B, C. So I did 1 tick mark, no tick marks, 2 tick marks. Sorry, arcs. So I need to go in the same order. 1, 0, 2. You see it? 1, 0, 2. So E, B, C. Easy one right here. Let's go through it quickly. Reflexive property of equality, shared side, means I can add tick marks to my picture. Those are obviously congruent by side, side, side. A, B, C is congruent to triangle A, B, C. Ooh, what about this one here? It's side, angle, side, right? You have to be careful. Here's what some students do. They look at the picture, they're like, ooh, tick marks. Side, and then we've got an angle, and then we've got a side, and then they stop and they write that as their answer. But you have to examine both triangles. They are both on trial for being congruent to each other. So when I go examine the other triangle, oh no, that angle is not between the sides. So these don't even match at all. My evidence doesn't even match. They're telling 2 different stories. So I put not possible, not possible. Some students get excited and they fill out the congruent statement. They say ABC is congruent to DEF by not possible. Well, that doesn't even make sense. You can't say they're congruent by not possible. So you put not possible in both blanks. They are not congruent, so don't even finish the congruent statement. Okay, I'm going to go through this one quickly because I want to get to some other examples. Reflexive property of equality, angle, side angle. Vertical angle. Uh-oh, but where is the angle? We have to be careful. There's an angle, but it's not between the sides. So if I were to write that out, I would get in trouble because I'd be writing a bad word on my homework. And so we write not possible in both blanks. And it's because of where the arc was. It was not between the sides. So these triangles might be congruent, but we do not have the right evidence. They might be, we don't know enough. Okay, this one's all good though. Similar picture, except this time the side is between the angle, angle, side, and then angle. Angle, side, angle. I want you to think about this one for a while. I'll talk about it in a moment. I want you to think deeply, maybe use the Isosceles triangle theorem. You're all saying not possible. But doesn't the Isosceles triangle theorem say if two sides are congruent, then the angles opposite are congruent? So don't I do this? And then I've got like angle, angle, side. Good job. Y'all found the flaw. Just because I agree that that is the Isosceles triangle theorem. And I agree you need to put an arc here and an arc here, but you need to put a double arc here and a double arc here. Because no one told us that the angles from the first isosceles triangle were congruent to the angles from the second isosceles triangle. For all we know, AB and BC, those are set in stone, the length, right? But what about that vertex angle? Those sides could do this or this. We could get all sorts of triangles out of this. We could have this one for the first triangle, and then for all we know, the second triangle might look like that. We don't know the angles. We know they match each other, but we don't know that the angles from one match the angles from the other. So although we were close on this one, we were trying to use a really good theorem, but it still was not. Not all isosceles triangles are congruent, so not possible to prove. The world may never know. All right, quickly with this one. Side, angle, side, sassy. Okay, I wanted to do one like this, and then we can end. What do those arrows mean? Because I want you to be very careful. Arrows do not mean tick marks. Arrows do not mean congruent. Okay, so when you get a triangle on your homework that has arrows, that's not S. That's not a side. So don't think that it's evidence of side. But what you can do is you can use the theorems from old, alternate interior angles, corresponding angles. You can use all of those. So by the alternate interior angle theorem, I can add angles there. By the vertical angle theorem, I can add angles there. And if I use this transversal, by the alternate interior angle theorem, I can add angles there. So when you see parallel lines, you need to add angles to your picture, not tick marks, no sides. Okay, are you guilty of being congruent? You're funny. Yep, black sheep. Sorry, we gathered so much evidence, but it wasn't the right evidence. We don't know if these are congruent. Not possible, not possible, because angle, angle, angle was one of the ones that didn't work. So do you write AAA in the blank? Is that what you write? No, it's not an approved piece of evidence. So you write not possible in both blanks. All right, the rest is up to you. I need you to try that homework, and I need you to ask me about the ones that you were confused about on Monday.